Hello everyone. In this video I'm going to talk about JUnit. JUnit is a tool available in Java for doing unit testing. Unit testing is the lowest level type of test, usually very close to the code, where it tests methods and functions, components, etc. to ensure that the code is functioning properly. And in this example I have Eclipse open and I have two class files, one called myUtilities and one called myApplication. The myUtilities class file has two methods in it, qubit and count spaces, and they're really quite simplistic, but for our purposes they'll work quite well. When we do unit testing, one of the common approaches is to create a test for each method separately so that we can test each individual method or all the methods together, and we'll walk through how to do both of those things here. And just by way of familiarity, the qubit method is a simple method that returns the cube value of any integer provided. That integer is, in this example, n in our parameter list. And then count spaces takes a string and just counts the number of space characters in that string and returns the number of spaces. So if I move over to my applications, the driver program here, so I am instantiating my utilities class. I have two variables, mynum and myString, and I use mynum to call the qubit method and myString to pass into the count spaces method. And if I run this, I can see that 3 cubed is 27, which is correct. And then of course the number of spaces, and this is my string, happens in this case to be 9. So we can use these values as part of our test suite. And JUnit uses a couple of terms. One is test case and the other is test suite. A test case is a unit test that we would apply to a single method, and a test suite would be a collection of test cases that we could run all together and run either of those two types of JUnit tests separately. So for example, we could test an individual method if we happen to make a change to it. One of the reasons that we use unit testing is by keeping them granular down to the method level. If we make a change to a method after we have created a test for it, we can rerun that test to confirm any of the characteristics that we had set up, or we can modify the test to add any functionality that we may have added to that method. If we run the test and it's successful, and we change the code in the method, and then we run the test again, and the test fails, that's an example of what's called regression. Regression is when changes to the code cause a new problem or regress back to a previous problem. So the most common approach is to set up a set of tests, make sure that they are functional and do not fail with valid values. And then when we need to make changes to the code, we update the tests. We want to make sure that any changes to the logic of the code will be caught by the test if there's any kind of failures. We'll walk through a couple of examples of this. So the first thing I want to point out is that this is a kind of a standard setup for packages in Java. So I have my project and I have a package here called my application, and I have my two classes inside that package. And so let's go to my utilities. And what I want to do is create our first test case based on this qubit method. And the way in which I do that is I come over to my package explorer, right click, and I go to new, and JUnit test case is the option that I want to select. And in this dialog, there's a couple of things to pay close attention to. One of which is the package. General convention is that we keep our test versions of our classes in a separate package. That way they do not get deployed with production code. When we create a test case, it actually creates a separate Java file that will contain our testing code based on the method or the class that we're testing. So what I'm going to do is I'm going to change the package from my application and put in the word test. And that's going to create a new package where we can collect our test files. I'm going to call it qubit test. And there's a bunch of stubs, different types of things that you can do where you can insert code that would be run prior to or after the method that you're testing. In a testing environment, sometimes you need to have some sort of external connections to databases or files, or possibly run some pre-process so that data is set up that your method requires in order to operate. In this case, we won't need that, so I'll skip over it, but just to let you know that that exists here. I'll hit finish, and now you notice that I have a qubit test.java. That's a Java file, and you notice I have a package over here now called tests where that qubit test program is located. So the first thing that you'll notice is this looks similar to our qubit method in a sense, but it is actually a separate class, and it has some code in here that you may not be familiar with. One is the import statement, which is bringing in JUnit, what's called assert. This is a library, and we'll use a command out of that. And it creates an initial stub for our test method. This method is going to actually communicate with the qubit method in my utilities class in order to run a test on it. And you also notice that on line 11 here, it has a line that says fail with a string inside. Fail is a JUnit command. If I were to run this program right now, in the lower left, I get a panel here that says JUnit, and it says that my test run failed. You notice it says failures 1. Well, the reason it failed is this is just stubbed off, and it's forcing sort of hard coding a failure. So I can actually just delete that. So the first thing that we need to do is we need the instantiation line to be the same as what we have in our demo program, which is this my utilities instantiation. So I'm going to copy that and paste it right here. And I'm just going to change the name of this though, just so I can keep them separate. That's mostly for me. The JUnit doesn't really care what I call this. And then what I need next is a variable to store the result of calling that method in my utilities. So qubit, if we look here, it returns an integer, right? So I'm going to create an int. I'll just call it, output. That could be anything really. Qubit 3. So what this is going to do is it's going to call the qubit method in this instance of the myUtilities class library, and the result of running the qubit method is going to be stored in my output variable. Keep in mind that we're inside of this test program. We're not running the myApplication class itself. And then we're going to use, I mentioned earlier that JUnit has a library here that was imported. We're going to use the asserts equals method of the JUnit library. And this takes two parameters. One is what I expect the output to be. We know when we ran this previously, we had a value of 27, right? 3 cubed is 27. And so that's the first parameter of this method. And the second is what we actually get. And in this case, it's going to be the output variable. Okay. And I'm going to save it. And if I run this now, you notice that my JUnit panel shows, it might be difficult to see, but it's a small green check mark, and the progress bar is also green. It shows failures are 0, and it ran 1 test. That means that this test succeeded. If I were to change this expected value, let's say, now obviously this doesn't make sense because 3 cubed is not 28, but just for demonstration purposes, if I have a value here and the output of calling that method for whatever reason comes back not matching that value, then this test fails. Now there's an X on my test case, and our progress bar is red, and it says failures 1. So this unit test is done. I can use this for any kind of values that I want. If I wanted to change these, let's say I change this to 2. Obviously, if I run this now, it's going to fail because 2 cubed is not 27. It's 8. So if I run this, change those values, and now it works. So I can come into this and test any set of values and output that I might be interested in testing. Now I'm going to go back to my utilities class. Now I want to create a unit test for the count spaces method. I go through the same steps. I go back to my package explorer, right click, JUnit test case. I'm going to change this to test so that I can store that in my test package. And I'm going to call this test count spaces and finish. Same structure. I don't need this fail like we did before. That's just that sort of placeholder. And I'm going to approach this in a similar way. I need to have a copy of instantiation. Now I could type that myself, but just to make sure that I have the same syntax. And again, change the name of it. Now this time, this method also returns an integer. So my output variable can be int again. Just use the same one, that's fine. Test utils dot count spaces. Now in this case it's a string, and that string was a little bit lengthy, so I'll just copy this. I want exactly the same data that I used in my initial run when I was manually testing, just to make sure that I'm looking at the same values and get this expected output. Right. There we go. And then I do the same thing as we did before, the assert equals. And if you recall, the output of the count spaces in this particular case with this string was 9. And then what I actually get with my little test run here, and when I run this, it worked correctly. The test passed. I have 0 failures. I have the green bar. Again, if I change this, I'll take out one of the spaces, and I run this again, and now it fails. And the reason is because I changed that string. And again, we can use this for any kind of data the same way, as long as we're working with the same data types and we know what the expectation is. And so the last thing I wanted to show you was how to create a test suite. We now have the qubit test, and we have the test for the count spaces. And as I said earlier, you can run these individually like we have been in this experiment, or you can create a test suite. So to create a test suite, I go back again to the Package Explorer, right click, go to New, and in this case I'm going to go to Other, and scroll down. You'll see JUnit here, and I'm going to select Test Suite, hit Next. And in this case, I want to make sure that I give it the package name where my tests are. You notice that it populated the list down here for me. And there's the qubit, the 2 tests for the 2 methods that we created. And then I hit Finish. So this is the test suite. Notice that I have my 2 test cases. And in this case, it's looking for the class files, which are created when we ran those earlier. Now I can put code in the all tests method to sort of customize this, similar to what I talked about earlier about running some pre-code or some post-code. But in this particular case, I don't really need to. So I'm just going to run this as is. Now I get the green bar. Notice that if I open this up, it shows me all of the tests. If I had, additional tests, they'd all be listed here. It shows that 2 tests were run, and there were 0 failures. Okay. If I were to go back and let's say, do that same thing where I change one of these, as long as I save it, and run this again, notice I have a failure. It ran 2 tests, I have 1 failure, and I can see the failure by finding this one that has the X on it. If I were to see a failure like that, I would just go back to the test case and work with that test case to do a little bit of discovery to see where the error is. So that all tests is my test suite. It runs all the tests that I created. If I need to go back to one of the tests and do some work to find out where an error is occurring, right, I can make that change as long as you make sure you save it until you get to the point where all of your tests pass. As a reminder, regression is a situation where now that we have all these tests in the test suite, if I were to come back to one of these methods and make a change to the code, I would want to then rerun the test case until I took into account all of the possible test case issues, anything that might fail. Some common examples are like division by 0, logic issues with regards to maybe there's a formula that I need to calculate and I'm getting an answer, but the answer is not correct. Maybe there's a range of values. A really common example is, let's say, age. Age is a good example because there's a range, an effective range. Age is never measured in negative numbers. We usually don't call someone 0 years old. So those would be 2 possible test cases we could check. And then also there's an upper limit, right? You could set an upper limit at like 125-ish, right? So whatever you decide what those limits are, that would be at least 3 separate things that you could place into one of these test cases to test against a method that, let's say, calculates someone's age based on a birth date or maybe a manual entry from a user or whatever. One last note, everything that I'm doing here is based on what's called JUnit version 4. There is a newer version that's out. You can find JUnit documentation online quite simply by Google search for that. And there are many YouTube videos and books out about JUnit as well. JUnit is an example of a testing tool. There are many, many of these tools on the market. We talk about JUnit here because it's kind of a component part of what we have available to us, both with Java and Eclipse and IntelliJ, all of the common IDEs. As always, if you have any questions, don't hesitate to let me know. And thanks for watching.